students, to move on with the application part of coordinate geometry, let's look into the problem penned on the board. Show that the points A, B and C are the vertices of an equilateral triangle. Now, how do we determine and say that the given points can be called as the vertices of an equilateral triangle? Definitely, the lengths or the distances between the pairs of points should be equal. That means the sides, the three sides of an equilateral triangle, as they are always equal, the length AB, length BC and length AC, when we calculate, should give us the same answer. Only then we can conclude that the given triangle with points A, B, C are the vertices of an equilateral triangle. So, to move on, how do we calculate distance AB, distance BC, distance AC? Definitely, again by using the distance formula. So, first, let's calculate distance AB. To calculate distance AB, what do we use? We use again the distance formula. What is the distance formula? It is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. In this case, whom do we assign the values of x1, y1 and x2, y2? Looking at the points that we have taken into consideration is A and B. Definitely, the coordinates of A can be assigned the value of x1, y1 and the point B as x2, y2. So, let's move on with the mathematical calculations. Therefore, distance AB, in the next step children, definitely we will have to substitute the values. What is x2? 1 minus what is x1? 1 the whole square plus y2 that is 6 minus y1 that is 2 the whole square. So distance AB will be equal to, now 1 minus 1 the whole square. 1 minus 1 is equal to 0. So here we have 0 square plus 6 minus 2. 6 minus 2 in the second term will give us 4. So 4 square. Therefore, distance AB will be equal to square root of, now 0 square is 0. So 0 square which gives you 0 and 0 value can be discarded. So you are just left with 4 square, that is equal to 16. Thus, distance AB will be equal to, definitely now children, root of 16 is plus 4 and minus 4. Which value do we discard in this case? Definitely the value with a negative sign can be discarded as we are calculating distance, and distance can never be negative. So over here we have only 4 units as distance AB. Therefore, we can say in other words, length AB is equal to 4 units. So this is the answer for length AB. Let's move on in the similar manner to calculate length BC, again by using the same distance formula. So over here, now we are calculating distance BC. Looking into the points considered, we will have to assign the values of x1, y1 and x2, y2. So over here, as we are taking the points x1, y1, we will take it as, for the point B, x1, y1, and for point C, it will be x2, y2. So to begin with the calculations, the first part is substitution after writing the formula. What is x2? Now if you look into the coordinates of point C, x2 is a binomial, 1 plus 2 root 3. So let's be careful when we are substituting. So x2 is 1 plus 2 root 3 minus x1 is 1. Let's not forget the square. So x2 minus x1 the whole square plus, let's move on, to substitute. y2 is given by 4 minus y1, that is 6, the whole square. Let's see what do we get in the first term. Now here we see inside the first bracket we have plus 1 and minus 1. So plus 1 minus 1 can be cancelled. They are the same numbers with opposite sign. So here we are left with only 2 root 3 the whole square plus, let's look into the second term, that is plus 4 minus 6, which definitely children gives us minus 2 the whole square. Thus distance BC is equal to, now here 2 root 3 the whole square. What is the answer? Let's find it out. So 2 root 3 the whole square will be 2 root 3 into 2 root 3. It is multiplied 2 times as it is squared. So 2 into 2 gives us 4, multiplied by root 3 into root 3 is 3. So the ultimate product is 12. So what is the answer for 2 root 3 the whole square? It is 12 plus minus 2 into minus 2 will give us, minus into minus gives us plus, 2 2s are 4 and plus 4 into this plus, plus into plus will give us plus. Let's do it on the next step. So this will give us 12 plus multiplied by plus is plus, 12 plus 4 is again equal to root 16. Root 16 is equal to plus 4 minus 4. As we have done earlier, the negative value will be discarded. So we are just left with distance BC is equal to 4 units, or in other words you can say, therefore length BC is equal to 4 units. So children, till now we saw length AB. What did we get? We got the same answer, 4 units, as we have got for length BC. Now what is left? Only the third pair to calculate the distance, that is considering the points AC. So we will have to find distance AC again by using the same formula. So let's continue and then let's check if they can be called the vertices of an equilateral triangle. Now we are calculating distance AC. So let's assign the coordinates as x1, y1 and x2, y2. So we are considering points A and C. So A can be considered as x1, y1 and C can be considered as x2, y2. So let's substitute as we have already done in the earlier cases. Distance AC will be equal to x2, that is 1 plus 2 root 3. Let's be careful as it's a binomial. So this is x2 minus x1, that is 1 the whole square, plus y2, that is 4 minus y1, that is 2 the whole square. So distance AC will be equal to, let's look inside the bracket. What do we have inside the bracket? We have again plus 1 minus 1, which cancels same numbers with opposite signs. So the value definitely is 0. So you can cancel it. So again we are left with the same number, 2 root 3 the whole square. Let's not forget the square. Plus inside the bracket 4 minus 2 gives us 2 the whole square. Let's solve it. As we have already done, children, 2 root 3 into 2 root 3 gives us 12. How did we get 12? 2 squared is 4, root 3 squared is 3, so 4 into 3 gives us 12. Plus 2 squared is 4, 2 2s are 4. Therefore, distance AC is equal to root 16. Therefore, distance AC again, let's take only the positive value of root 16, that is 4 units. Therefore, length AC is equal to 4 units. So what did we see now, children? In the last pair, and we calculated the distance between AC, the answer was just the same, that is equal to 4 units. So what can we conclude? We can say that length AB is equal to length BC is equal to length AC. So when all the three lengths or all the three sides are equal or congruent, can we call that triangle as an equilateral triangle? Definitely. So we will say as length AB is equal to length BC is equal to length AC, which is equal to 4 units each. Therefore, the points A, B and C are the vertices of an equilateral triangle. So what did we see, children, over here? What did we use over here? We used only distance formula to calculate the lengths of all the three sides, and depending on what is asked in the problem, we have seen if it's satisfying the given condition and we have proved what they have asked.